In this video, we're going to talk about similar figures. Specifically, we're going to discuss the characteristics, which will in turn allow us to be able to find missing sides of similar figures. The definition of similar figures is two figures that have the same shape and share specific characteristics. What are those characteristics? The first is ratios of lengths of corresponding sides are equal. Notice I said ratios of lengths, meaning that the actual measurement of the length is not going to necessarily be equal, but the ratios of those lengths of corresponding sides will be equal. Next, we have the measurements of corresponding angles are equal. Then we have the naming conventions dictate corresponding elements. So what does that mean? The way the different figures are named actually tells you the corresponding sides or the corresponding lengths. So you want to make sure that you look at the naming conventions to match up the appropriate lengths and angles. The last characteristic that we're going to walk through is there is a scale factor that relates the two figures to each other. For the first example, we are going to use the characteristics that we just discussed in order to find the missing side of one of the similar figures in a pair. Each pair of figures is similar, so we're being told this, we don't have to prove it. Find the missing side. Also, we're going to state the scale factor. So remember again that when we're looking at similar figures that we actually know are similar figures, the ratios of lengths of corresponding sides are equal. So we are going to set up a ratio for the first figure as 34 divided by 51 using the given sides. And I'm going to move this up just a little bit so we have enough space to write. Okay, and we are going to set that equal to the ratio of corresponding sides for the other figure, giving us x divided by 3. Okay, so either we can determine if we can reduce the fraction ahead of time, 34 divided by 51, or we can go ahead and cross multiply and see if we can reduce or multiply that way. So let's just cross multiply for the first one. So cross multiplying, we get 51 times x, or 51x, equals 34 times 3. I divide both sides by 51. Using the rules of divisibility, I know that 51 is divisible by 3 because the sum of the digits 5 plus 1 equals 6. 6 being a multiple of 3 means that 51 itself is divisible by 3. So I am going to divide both 3 by 3 to leave me with 1 and 51 by 3, leaving me with 17. So that gives me x equals 34 divided by 17. 34 divided by 17 is simply 2. So that means that the missing side is actually 2. Now, scale factor, what does that mean? The scale factor is a number that I can multiply every side in the smaller figure by to get the corresponding measurements in the larger figure, or that scale factor can be used to divide the numbers or the measurements in the larger figure to get the measurements in the smaller figure. So 3 times what gives me 51? We just did that down here. 3 times 17 gives me 51. Also, we know that 2 times 17 gives me 34. Therefore, our scale factor equals 17 for this particular example. Next, we have B, a triangle, or two sets of triangles. So we're going to do the exact same thing. 12 divided by 20 equals 3 divided by x. This time, I'm going to actually reduce the fraction first because we know that 12 and 20 do have common factors. The GCF, or the greatest common factor, of 12 and 20 is actually 4. So dividing 12 by 4, I'm left with, so I'm going to actually write the division by 4 here, and I'll be left with 3. And then dividing this by 4, I'm dividing 4 into 20. I'm left with 5. And over here I have 3 divided by x. And typically we would write it behind it just to have our notation correct. Okay, now cross multiplying, I have 3 times x, or 3x, equals 3 times 5. Divide both sides by 3. 3's divide off on both sides, so I have x equals 5. The missing side is 5. Scale factor again is found by determining the number that I can multiply the measurements in the smaller figure to get to the measurements in the larger. 5 times what will give me 24, right? 3 times 4 also gives me 12. Therefore, our scale factor here is 4. For our last example, you should notice that every single measurement in either of the two figures is labeled. But in order to get the missing side, we only need to determine it based off of one ratio. So I'm going to choose the smaller numbers to work with. So I have x divided by 36 equals corresponding side to x is 7. Corresponding side to 36 is 4. Cross multiplying, I get 4x equals 36 times 7. Divide both sides by 4. 4 divided into 36 is 9. 9 times 7 equals 63. Therefore, this missing side is 63. And our scale factor, and reducing actually helps you find the scale factor a little bit quicker, because we want to figure out what times 7 will give us 63. Well, it's right here. It's 9. And we can test that by multiplying all of the sides by 9. 10 times 9, 90. 4 times 9, 36. And 14 times 9, 126.